now we will solve quadratic form equations. So what we're going to do is factor the quadratic form. We can keep factoring if necessary. Or if possible, or if you want to. Otherwise, what you're going to do is set each factor equal to 0 and solve. Otherwise, use the quadratic formula. Or you can use the square root method if you need to. So treat these as if they were your regular quadratic equations. So the quadratic formula for ax squared plus bx plus c, it's just x equals negative b plus or minus the square root b squared minus 4ac all over 2a. If we bump the exponents up, then the quadratic formula for this would be x squared equals negative b plus or minus the square root b squared minus 4ac all over 2a. And when we figure that, then we will square root both sides to get our value for x. And then if we bump it up one more time, we get x to the third equals negative b plus or minus the square root b squared minus 4ac all over 2a. And instead of leaving it as x to the third, you're going to cube root each side. So the degree of your middle term will tell you the degree of your x. Some answers are repeated, which results in a lower number of answers. So with that being said, since this is x to the sixth, technically there should be at most 6 answers. In this form, it may be you may only have 2 because some of them may be imaginary. With this one, we should have 4 answers. With the quadratic formula, it will be all 4 answers will be there. It's kind of hard to tell or show, but they will be there. If you were factoring, you should have at least 6 or 4 or 2. If you have more answers than what your degree states, then you've done something incorrectly, and I'd like to see why or how you came up with it. So let's solve the equations. So x to the fourth minus 25 equals 0. So this one we can factor. So this is x squared minus 5, x squared plus 5 equals 0. Set each of these up equal to 0. We're going to add 5 over, subtract 5 over, square root both sides, and when you do that, this will be x equals plus and minus square root 5, and then this will be x equals plus and minus square root negative 5. To finalize your answer, you can go x equals plus or minus square root 5, comma, plus or minus I square root 5. So here are our 4 answers. Positive square root 5, negative square root 5. Positive I square root 5, and then negative square root, or I square root 5. With the quadratic formula, when something cannot factor, the total number of answers will kind of be hidden or disguised. let's solve this one. So 45, 3 times 15 is 45, but if we negate both of those, adding those together, we'll get a negative 18. So with that, we'll have x squared, and then we'll have negative 3 and negative 15. Set each factor equal to 0, like you would any other quadratic. Add the 3 over, add the 15 over. Square root both sides, and remember when you square root both sides, you'll get x equals plus or minus square root 3 and plus and minus square root 15. And always simplify your square roots if needed, which in this case we did not need to. Let's look at a x to the 6th one. Let's see here, negative 30, that would be negative 15 and positive 2. And I like these because they are quick and easy. We don't have to do the AC method. So x to the cubed minus 15 equals 0, and x cubed plus 2 equals 0. X cubed equals 15, x cubed equals negative 2. Cube root both sides, and remember when you cube root, you don't need the plus or minus. That's only if your power is even when you need the plus or minus. So this will be cubed root of 15 and cubed root of negative 2. We have only 2 answers because technically our other 4 answers are imaginary, and we would have to go about a different way to find those, but we are really looking for our real answers. And I know we did find some imaginary numbers too, but the cubed, that's a little harder to find. Takes a little more planning. Okay, let's look at this one. We would have 24, so that would be 8 and 3 to make negative 5, but 8 has to be negative. So we have 2x to the 4th minus 8x squared plus 3x squared minus 12 equals 0. Factor by grouping, so we'll have 2x squared. So that's x minus 4, or x squared minus 4, excuse me. And then we'll have a 3 that comes out, so x squared minus 4 equals 0. So we'll have 2x squared plus 3, and we'll have x squared minus 4. And if you need to, you can factor that out some more, which would be x minus 4, x plus 4, or you can add the 4 over and square root to get plus and minus. Oh, not 4. That's supposed to be 2. I'm sorry. That's supposed to be 2. So if you add the 4 over and then square root both sides, you'll get plus and minus 2 as well. So 2x squared plus 3 equals 0. I'll work with this later. So 2x squared equals negative 3. Divide by 2 to both sides, so x squared equals, not square root yet, negative 3 squared. Square root both sides, so x equals square root of negative 3 halves. That's okay if you want to leave it that way, but I'll show you how to finish this properly. Then with this one, we have x squared minus 4 equals 0, x squared equals 4, square root both sides, we have x equals plus and minus 2, or you can see we have plus and minus 2 when we factor. Now, this one, we have square root of negative 3 over square root 2, multiply square root 2 to both top and bottom, so we have a 2 in the bottom. 3 times 2 is 6. That negative will come out as an I. Oh, and we have plus and minus in front because we square rooted. So x equals plus or minus I square root 6 over 2 and plus and minus 2. So there is our 4 answers, and yes, 2 of them are imaginary. Eight x6 minus 4x third minus 18 equals 0. Now with this one, if you do not want to try to factor it, you can actually do the primability test to see if you can factor. So this would be b squared minus 4ac, which would be 4 or negative 4 squared minus 4 times 8 times negative 18, which would be 16 plus 576. Add that together, that would be 592, which is not a perfect square. So, with that being said, we're going to use the quadratic formula. However, you already did half of your work, because here is square root b squared minus 4ac. So, x to the third equals negative b plus or minus the square root b squared minus 4ac all over 2a. So it's all the same except we have x to the third. So x to the third equals negative 4 plus or minus the square root of 592. Because I already did the work here, I can just put that number there. 2a, that'd be 2 times 8. X third equals 4 plus or minus, with this one, I think that's 16 times 37 when you factor that. And then we'll have 4 square root 37 all over 16. Now, take a look at this. We can actually rewrite this as 2 different fractions. Or since 4 and 4, both of these 4's can go into 16, we can actually reduce them. Or in this case, we'll just go 1, 1, and 4. So we'll have 1 plus or minus the square root of 37 over 4. And then we're going to cube root both sides. So x equals cubed root of 1 plus square root of 37 all over 4. Technically, there is a radical in the denominator, but if you can get to this point, you don't need to rationalize your denominator if you use the quadratic formula. This will be okay to submit. One more, and then we'll cut the video. 2x to the fourth minus x squared minus 2. We don't have factors of negative 4 that add to 1, or if you want to do the primability test to make sure that we cannot factor this, because that would actually be a pretty good one to factor. But we will go through the test to make sure. So we'll have 1 plus 16, which would be 17. Well, 17 is not a perfect square. So we need to go ahead and do the quadratic formula. Now take the middle term, that's x squared, equals negative b plus or minus the square root b squared minus 4ac all over 2a. Same formula, just this x out in front is different. So x squared equals negative 1 plus or minus the square root. Here's b squared minus 4ac, we get 17 all over 2 times 2. X squared equals 1 plus or minus the square root of 17 all over 4. Square root both sides, so x equals plus or minus the square root of 1 plus or minus the square root 17 over 4. There's a radical in the denominator. Luckily, the denominator is a perfect square. So we'll have the numerator, and then we'll have a denominator of 2, because we can actually split this up into a numerator and a denominator. Oops, got ahead of myself here. So then the square root of 4 is 2. So that's how I got that. So if you can square root something, go ahead and do that. If there's a perfect square or a perfect cube under the radical, go ahead and figure that, and then there won't be a problem with that. With this one, cubed root of 4, the 4 is not a perfect cube, so we'll just leave it as that answer. So, but if you did leave me this answer, I probably would not count it wrong, but if you did take that one extra step, that will be awesome. So this will conclude this video.